Jai Shri Ram. Welcome to Civil Engineering Infrastructure (CEI), the platform where real construction knowledge meets field experience. Here, we don't just discuss theories. We share what truly happens on site, in the mud, dust, and with the machines. This is where civil engineering comes alive. Beyond books, beyond classrooms, straight from the ground. Today's topic is Highway Construction Process, Part 3, DBM, Dense Bituminous Macadam. In this session, we'll understand step by step how the DBM layer is prepared, what key technical factors to consider, and what field challenges engineers face in real execution. Presented by Air. Rahul Pandey, who brings his field execution and practical learning experience to teach you the lessons that aren't found in textbooks, only on site. If you wish to continue learning this kind of real, practical knowledge that's rarely taught in college, then subscribe to Civil Engineering Infrastructure (CEI) and hit the bell icon so that YouTube reminds you a new learning video is live. Keep watching, keep learning. Before we begin the DBM process, let's take a quick recap of what we learned in Part 2. From ground to base, subgrade to WMM. In the previous module, we prepared the foundation of the road. Starting from subgrade, moving up to GSB and WMM layers, each one contributing to the strength, stability, and drainage of the pavement. Let's recall how each layer plays its vital role in building a durable base for DBM. Subgrade, MoRTH 305 IRC 37. This is the natural soil layer, the true base of every road. Here, proper CBR value and compaction are essential. Before placing GSB, we check the moisture content and density and ensure the level tolerance remains within plus or minus 20 mm. Because a strong subgrade is where a strong pavement begins. GSB Granular Subbase, MoRTH 401. The GSB layer provides drainage and load spreading capacity. It uses well-graded, clean, and angular coarse aggregates. Thickness usually varies between 150 to 200 mm, depending on the design. Compaction should achieve 98% of maximum dry density (MDD). In short, GSB not only strengthens the base but also ensures proper drainage for durability. WMM Wet Mix Macadam, MoRTH 406 IRC SP 77. This layer is made with mechanically mixed aggregates, combined with water at optimum moisture content. It's laid using a Paver finisher and compacted by a vibratory roller. Target compaction, 100% of MDD. The WMM acts as the final layer before bituminous work begins, providing a stable, uniform platform for DBM laying. CEI Engineer Note: before starting DBM work, ensure that the WMM surface is even, dense, and free from loose particles. Any undulation must be corrected with a leveling coat. Footer line: if the foundation is strong, every layer above stands with confidence. Jai Shri Ram. Now, let's begin with the layer that defines both the strength and lifespan of the road. DBM, Dense Bituminous Macadam. It may look simple, but it's the true backbone of the road structure. In this presentation, we'll understand how this bituminous layer is designed, prepared, and executed as per MoRTH and IRC standards. Because on the field, design and drawings alone aren't enough. You need experience, precision, and perfection in execution. For an engineer, it's not just a road. It's a structure that reflects responsibility, hard work and knowledge. Technical references. MoRTH Section 507, Dense Bituminous Macadam. IRC 37, 2018, Design of Flexible Pavements. IRC 111, 2009, Construction and Quality Control of Bituminous Mixes. CEI Impact Line. Every road defines an engineer's identity, where hard work, knowledge, and responsibility meet. We are not just building roads. We are building the foundation of our nation. Jai Shri Ram. Now, let's uncover the real strength of DBM. Strength lies in the mix. The durability and lifespan of a road depend entirely on how accurate and balanced your mix is. A. Aggregates. Aggregates form the skeleton of DBM. They must be clean, angular, and crushed stones. Los Angeles abrasion less than or equal to 35%. Aggregate impact value less than or equal to 30%. Water absorption less than or equal to 2%. Flakiness and elongation combined less than or equal to 30%. Because moisture and weak stones are the first to fail under load. All parameters must conform to MoRTH Table 500-17. CEI Engineer Note. A great mix starts with clean, graded aggregates and accurate binder content. Remember, the plant operator's precision defines pavement life. B. Bitumen. Bitumen binds everything into one strong structure. Bitumen grades used are VG 30 and VG 40 as per MoRTH Clause 507.2.2. It must be heated to 150-165 degrees C, VG 30 or 160-170 degrees C, VG 40, before mixing. Viscosity and temperature must be strictly controlled. No foaming or oxidation during heating, that's where quality starts to fail. C. Mineral filler. Fine but essential, ensures interparticle bonding. Cement, limestone dust, or hydrated lime may be used. The filler must pass through 0.075 mm sieve, as per IS 2386 Part 1. Technical references. MoRTH Section 507. IRC 111, 2009. IS 2386, Testing of Aggregates. Quality is not an act, it's a habit that defines the road's life. Jai Shri Ram. Now we reach one of the most critical stages, mix design. Because here we decide the road's durability and performance. Designed for durability, proven by performance. A. Objective of mix design. The main goal is to determine the optimum bitumen content, OBC, for maximum stability and durability. Meeting MoRTH Section 507 performance criteria. Maintain air voids between 3-5% for flexibility and strength. B. Laboratory tests, Marshall method. Key lab tests include bulk density and theoretical specific gravity, GMM. Stability and flow value, ASTM D1559 MoRTH 507.2.3. Voids in mineral aggregate, VMA. Voids filled with bitumen, VFB. Finally, determine optimum binder content, OBC, graphically. CEI Engineer Note. The road's life begins in the lab. Precision here defines performance on site. References. MoRTH Section 507. IRC 111, 2009. ASTM D1559. Every layer's design is a responsibility. Road strength begins here. Jai Shri Ram. Now comes the stage where lab design meets field reality. Job mix formula, JMF. From lab mix to field reality. A. Preparation of JMF. JMF is based on approved trial mix results. Binder percent, gradation, and temperature are finalized as per MoRTH Table 500 to 18. Tolerance limit plus or minus 0.3% for binder content. CEI Engineer Note: a perfect mix design is useless without perfect execution. The field verifies what the lab promises. B. Approval and field verification. Engineer in charge approves JMF after review. Verify plant calibration before production. Collect core samples for density and bitumen content check. Ensure site values match lab results. References: MoRTH Section 507, IRC 111, 2009, IRC SP 79. Design should not just exist on paper, it must reflect on the road. Jai Shri Ram. Now comes the moment where design turns into reality. Strong base, perfect laying foundation of durability. A. Preparation before laying. Check WMM surface for level, dryness and cleanliness. Apply tack coat, ₹1 or ₹2, at 0.25 to 0.30 kgm superscript 2. With temperature between 160–170 degrees C. Ensure safety barricades and road signage are in place. CEI Engineer Note: DBM's strength depends not only on materials, but also on how perfectly it's laid. B. Laying of DBM mix. Mix transported in covered tippers, tarpaulin sheets. Site temperature 150–165 degrees C. Laid using sensor paver finisher to maintain proper grade and camber. Layer thickness min 50 mm as per design. Ensure continuous paving, avoid cold joints. References: MoRTH Section 507, IRC 111, 2009. A perfect beginning always leads to perfect results. Jai Shri Ram. Now comes the stage that defines true strength. Rolling defines strength, control ensures quality. A. Compaction process. Initial rolling tandem roller 8-10T immediately after paving. Intermediate rolling vibratory roller 8 to 10 passes. Final rolling pneumatic tired roller for smooth finish. Achieve 98% Marshall density. And finish before mix temperature drops below 100 degrees Celsius. CEI Engineer Note: quality control is not inspection, it's prevention. B. Field quality control. Temperature check at both plant and site. Core density tests IS 1201 to 1220. Bitumen content test using centrifuge extractor IS 138 to 6. Surface level tolerance plus or minus 6 mm. References: MoRTH Section 507, IRC 111, 2009, IS 1201-1220. Quality is not control, it's a culture of responsibility. Jai Shri Ram. Now let's talk about the most critical factor, temperature. Temperature defines quality, control defines longevity. A. Temperature control. Mixing 150–165 degrees C. MoRTH 507.2.2. Laying greater than or equal to 140 degrees Celsius. Compaction begin above 110 degrees Celsius, finish before 100 degrees Celsius. Monitor continuously with digital thermometer. Reject mix if variation greater than 15 degrees Celsius within one truckload. B. Causes of temperature loss. Delay between mixing and paving. Improper tarpaulin cover on trucks. Cold or windy conditions. idle paver or roller due to traffic delays. CEI engineer note. Even a perfect mix fails if temperature control fails. Every degree lost means a meter of strength lost. References: MoRTH Section 507, IRC 111, 2009, IS 1201-1220. Every degree of control guarantees road life. Jai Shri Ram. Now we move to the stage where field teaches the real lessons. Problems in field are lessons for perfection. A. Common field problems. Segregation, uneven loading or dumping from height. Temperature loss, long haul or delay in paving. Uneven surface waves, poor paver screed or slope. Roller marks, late or insufficient passes. Cracks, open texture, low binder or poor compaction. CEI engineer note. You don't fix mistakes on the road, you prevent them before the first load. B. Preventive measures. Maintain continuous mix supply, avoid cold joints. Cover all tippers with tarpaulin. Use skilled paver and roller operators. Monitor temperature every 20 minutes. Begin compaction immediately after laying. References: MoRTH Section 507, IRC 111, 2009, IRC SP 79, IS 1201-1220. Every mistake teaches a lesson, every correction defines identity. Jai Shri Ram. Let's now focus on what defines every responsible engineer: safety. Safety first, productivity always. Personal protective equipment (PPE). Helmet yellow, engineers, white, supervisors. Reflective jacket, high visibility type. Safety shoes, steel toe, anti-slip. Gloves and goggles for bitumen work. Earplugs during roller or plant operation. Dust mask during hot mix spreading. CEI engineer note. Your safety gear is your license to work, never start without it. References: MoRTH Section 112, IRC SP 55. A safe engineer is a successful engineer. Jai Shri Ram. Not every road is built in daylight, sometimes we build in the dark. Discipline saves life, carelessness costs it. Good site practices. Ensure barricading and signage before work. Provide flagmen and cones for diversion. Keep first aid box and fire extinguishers ready. Avoid crowding near rollers or hot mix. Conduct toolbox talk before every shift. Never stand behind a moving paver or roller. Night work and electrical safety. Ensure lighting and reflective cones. Check generator grounding and safe cabling. Workers must wear reflective bands. Avoid work during heavy rain or poor visibility. CEI engineer note. Safety is not a pause in work, it's the foundation that keeps work going. References: IRC SP 55, IS 3764. Safety is a habit and an engineer's true identity. Jai Shri Ram. Now we arrive at the stage that proves engineering integrity. Quality control tests, lab and field. Testing defines strength, verification ensures perfection. A. Laboratory tests. Aggregate tests, IS 2386 gradation, AIV less than or equal to 30%, flakiness less than or equal to 30%, water absorption less than or equal to 2%. Bitumen tests, IS 1201 to 1220 penetration, softening, viscosity, flash and fire point. CEI engineer note. Every test is proof of your engineering honesty. B. Field tests. Temperature control, mixing 150-165 degrees C, laying greater than or equal to 140 degrees C, compaction greater than or equal to 110 degrees C. Density, 98% of Marshall density. Binder content, verified by centrifuge reflux method. Thickness, 50 mm minimum. References: MoRTH Section 507, IRC 111, 2009, IS 2386, IS 1201-1220. Quality is proven through every test, and every test is a new lesson. Jai Shri Ram. Now we move to the most important stage of any construction project: quality records and documentation. Because as we say at CEI, quality assures strength and records ensure accountability. It's not enough to just perform a test. What truly defines professionalism is how well you record, verify, and maintain those results. A. Documentation and record keeping. Every engineer must ensure that site records are complete, accurate, and traceable. Maintain your daily QC register, including all test results, chainage, and dates. Record temperature and density charts daily. Preserve all source certificates, whether it's bitumen, aggregates, or filler materials. Prepare a weekly QC summary sheet for the client, showing test trends and observations. Keep core test results mapped with GPS or chainage references, so they can be verified anytime. Because documentation isn't just paperwork. It's the engineer's signature of accountability. B. Engineer's responsibility. Every engineer on site must treat records as part of quality control. Verify every test with date and signature. Cross-check calibration records for all testing equipment. Ensure that lab and site results correlate within permissible limits. Present a summary during joint inspections, showing consistency and reliability. These steps build trust between the contractor, the client, and the engineer. Technical references: IS 2386, Part 1-5, Testing of Aggregates. IRC SP 79, Bituminous Mix Design. MoRTH Section 900, Quality Control and Records. CEI Engineer Note: quality control is not inspection. It's a habit that builds credibility. Quality control isn't just testing. It's a culture of excellence. Jai Shri Ram. And now, we reach the final summary and key takeaways. From knowledge to practice, that's true engineering. Technical recap. 1. Keycap material selection and mix design, foundation of every road. 2. Keycap job mix formula where lab meets field. 3. Keycap layer preparation, cleaning and tack coat. 4. Keycap laying, temperature 150-165 degrees C, thickness 50 mm. 5. Keycap compaction, achieve 98% Marshall density. 6. Keycap field control, temperature, density, binder. 7. Keycap documentation and safety discipline of a true engineer. Key learning outcomes. DBM is a structural layer, not just a mix. Quality, temperature, and timing define performance. Field tests prove, not assume, results. Safety and discipline are non-negotiable. Documentation builds trust and accountability. CEI Engineer Note: you are not just building roads. You are building reliability, safety, and pride. References: MoRTH 507 times IRC, 111 times IS, 2386 times IS, 1201-1220. Every road is an effort, every engineer, an identity. Jai Shri Ram. With this, our DBM module concludes. the layer of strength, precision, and durability. Next, we begin our new journey. Bituminous concrete, BC, the final ride to perfection. The BC layer. Final wearing course over DBN. Provides smooth surface and waterproofing. Minimum thickness 40 mm. Bitumen grade VG 30 or VG 40. Mix design as per MoRTH 507 and IRC 111. CEI Engineer Note. Perfection isn't an act, it's the habit of a responsible engineer. Next video topics. Material and binder selection. Laboratory mix design. Job mix formula and trials. Laying and compaction. Surface quality checks. Common issues and solutions. References. MoRTH Clause 507. IRC 111. Every inch, every degree, every test defines quality. Jai Shri Ram. Jai Shri Ram. You were watching Civil Engineering Infrastructure CEI, the channel dedicated to practical construction knowledge. From field experience to classroom learning. Our mission is simple: to share real engineering knowledge that every engineer deserves. If you haven't subscribed yet, please subscribe now and hit the bell icon to keep learning what's not taught in college. Follow us for daily site updates, construction insights and real field learnings. Instagram @CivilEngineFra. Facebook CivilEngineFra. LinkedIn Rahul Pandey Civil. Knowledge is power, but only when shared. Thank you from Civil Engineering Infrastructure CEI. Stay safe, keep learning, and keep building. Jai Shri Ram. Jai Shri Ram. We sincerely thank you all for watching this DBM process presentation till the end. Your time, attention, and dedication mean a lot to us. This knowledge will strengthen your field execution skills and build more confidence for on-site performance. Let's meet again in the next video, Bituminous Concrete, BC, layer, where the journey of perfection continues. Knowledge grows when shared. Keep learning, keep building. Where hard work meets precision, true engineering takes shape. Jai Shri Ram.